Hi, I'm Dan.
And I'm Tiana, and this is the Accident Replication Machine for Wearable Devices.
There are 20 million unreported bike accidents every year. Many of these crashes end up in concussions or other conditions that can cause health problems if ignored.
Originally, we wanted to create a wearable device that determines accident severity, but we discovered they already exist. All devices advertise the accident detection, but there was no independent third party to validate their claims.
So we decided to find out what is the extent to which smartwatches can detect accidents and establish their severity.
This clip shows our project's main objective. Above is the model accident that we analyzed, and below is our Fusion 360 simulation. Follow the wrist of the dummy as we are tracking and extracting the position of the smartwatch. We will take this position data and feed it to the machine below. Now observe the vertical carriage as it moves in sync with the dummy's wrist. Through this process, we are effectively replicating the motion of the wearable device during an accident. This will allow us to validate if the smartwatch's accident detection works as expected. We started with the ambitious goal to design, build, and program an accident replication machine and use it to test an Apple Watch. This is what we envisioned for a procedure. We would extract the data from a stage accident, develop a simulation machine, and then test a few smartwatches.
We used a video modeling tool to analyze a staged bike accident. The data we extracted had to be filtered out to eliminate errors. Notice how choppy the raw data is compared to the final version. We use several algorithms to smooth the data, and we've got over 300 data points for a third of a second period. We can replicate the procedure and generate multiple testing scenarios.
In parallel, I started working on the design of the actual machine. One thing I did not expect was the number of iterations we needed to make things work. For just 1 year, I went back 5 or 6 times until it was perfect. Our progress was incremental. With each iteration, new constraints came to light that we had to address. You can see the evolution of our machine from sketch to the first prototype attempt here.
In this clip, you can see our first scaled working prototype of the X-axis and carriage. For safety reasons, our scaled prototype will simulate the accident 10 times slower than in real life. We calculated a 2.4 to 1 gear ratio, which will allow the carriage to reach the maximum speed of 1.2 meters per second.
Unfortunately, our first motor driver was faulty, which set us back 2 weeks, and we were unable to test our machine. That's our next step. Future iterations will use faster, stronger motors and have metal parts to replace the 3D printed ones in order to withstand the stronger accident forces. We made a lot of progress, and we're very optimistic about the machine becoming a reality. Thank
Thank you
you for
for watching.
watching.